All right, so more properties of logs, or I guess the same properties, but more practice, right? So, and again, I think I mentioned this on the last video that you could solve the rest on the page and then take a look at the end of the video. That's fine. I'm just going to walk through these examples. So if you get stuck, need some clarification, then that's perfect. You could go ahead and watch. Okay, so natural log of e divided by 2. So, again, let's go here, this nice purpley color. So natural log of e minus natural log of 2. Well, the thing is that natural log is log base e, right? So you could be thinking, oh, wait a minute, log base e of e, well, those just count exponents. Minus natural log of 2. So this is like e to the first, this was the base, that's just 1, right? So 1 minus natural log of 2, which was defined to be m. So there we go. Going to be natural log of 10 divided by natural log of 5, and then realizing that 10 is the same thing as 2 times 5, right, as a product. And anytime you've got a product, you could expand that. So it's natural log of 2 plus natural log of 5 over natural log of 5. And then we go ahead and substitute. So that's equal to m plus n divided by n. Okay. 32, I see that it's 2 to the 5th power. So that's natural log of 2 to the 5th. And this 5 can come out front. So we have 5 times the natural log of 2. And what was natural log of 2? M. So it's 5m. And like really that property, think about 2 to the 5th, that's the natural log of 2 times 2 times 2 times 2 times 2, right? So in theory, you could have expanded this out to the natural log of 2 plus the natural log of 2 plus the natural log of 2 plus the natural log of 2. One more. Plus the natural log of 2. There are 5. There are 5 natural logs of 2. So really, it's just that same rule. It's just an abbreviation, right? It's a quick way to get that. Okay, log of 2. Instinct maybe initially says, hey, that's m. Wrong, because this is common log, right? This is log base 10. So really, this is log base 10 of 2. And when you see it like that, then you can rewrite it as the natural log of 2 divided by the natural log of 10. And then, we already know that 2 is equal to m. And we've already seen what natural log of 10 is up here, right? That's that m plus n. So then we know that's m plus n. Excellent. Okay, log base 25 of 4. So I could think about that as the natural log of 4 divided by the natural log of 25. Remember, 4 is 2 squared. And 25 is 5 squared. So this 2 could come in front, and I'd get 2 natural logs of 2, which was m, and then 2 natural logs of 5, which is n, which reduces just to m divided by n. Now, one of the properties we haven't used yet is that if these are if both your base and what you're trying to take the log of, so this and this, if they're both the same power, like these are both squares, you could simplify it first. So I could have said, oh, well, wait a minute, that's the same thing as log of base 5 of 2, because those are both the square roots, respectively. And then look what that's natural log of 2 divided by natural log of 5, which is exactly what I had. So again, an alternate way to solve that. Okay, and then our last one, again, don't get deceived, that's common log, so log base 10. So we can say log base 10 of 2.5. So that's the natural log of 2.5 divided by the natural log of 10. And 2.5 is is 5 over 2, right? It's 5 halves. Natural log of 5 halves divided by natural log of 10, which is 2 times 5. So up here, I'm going to get a difference, the natural log of 5 minus the natural log of 2. Here, I'm going to get a sum, natural log of 5 plus the natural log of 2. So it looks like I have, n minus m divided by n plus m. So again, just some practice with those problems as well. Okay. Now, like this next one that says express them as a sum or difference of logarithms, and then basically it's just more practice, right? So the fact that there's a quotient here, don't be intimidated by the algebra. Log base 2 of x cubed minus log base 2 of x squared minus 9. And then again, it says express these powers as factors so that 3 can come out in front. So it's 3 log base 2 of x minus, and then this is a difference of squares, right? Log base 2 of x minus 3 times x plus 3. So because there's a product within that logarithm, I can break that up into a sum. Just remember, you're subtracting that quantity. So it's 3 log base 2 of x minus log base 2 of x minus 3 plus log base 2 of x plus 3. And then we would subtract or distribute that negative. So then 3 log base 2 of x minus log base 2 of quantity x minus 3 minus log base 2 of x plus 3. So there is our equivalent expression expressed as powers, and the powers as the factors and the sums and differences. I believe the next one we just go the other way, right? So these are both common log. So the fact that this is a subtraction means I could put it as a quotient, and I'm going to factor as I go too. So log of super parenthesis. Okay, so this part right here divided by this part right here, right? So it's all going to be in one log. But because I see some factoring, so like x squared plus 3x minus 4, that's really x plus 4 times x minus 1. And then this is x plus 3 times x minus 3, right? Difference of squares. This here could be x plus 6, x minus 1, and this is just x plus 3. So now that it's all in one log, now instead of dividing by a fraction, we can multiply by its reciprocal, still within that log. So now I have x plus 4, x minus 1 over x plus 3, x minus 3, and then this is x plus 6. Oh, just kidding. I said the right thing, just not following through. How about x plus 3? We did do the reciprocal, divided by x plus 6, and then x minus 1. So now I know that my x minus 1s cancel, my x plus 3s cancel. Yeah, I think that's it. So it does just say in a single logarithm. So then I could leave it as factors because they're still within that same log. So it could be the log of x plus 4 divided by x minus 3 times x plus 6. Yeah, so like there's our final, like I said, our final answer is an equivalent expression that we've written it into one logarithm. And again, just an exercise to practice those properties. While I'm thinking of it, something like struck me when I was simplifying this example. Where was it? Oh, yeah, the natural log of e, right? Something struck me as like, oh, maybe we should write this down as one of our properties. So I'm going to add this, an addendum. Maybe we'll put it in red because it will show we're adding this. That if you have log, like whatever, log base b of b to the x. So if your bases match, then all you get left is just your x. So like, again, that's just kind of the definition of what it means to be a logarithm. It counts exponents, right? So that's just an additional piece to that. So, okay. So I think I'll make one more video for the last part of those examples. But again, just like the last one, if this looks familiar to you and you want to just do them and check at the end of the video, that's fine too. The ultimate responsibility that you have for this section is to remember and know how to simplify logarithmic expressions.